Now a gun fires a shell at an angle of elevation of 30 degrees with a velocity of 2000 meters per second. The question says, what are the horizontal and vertical components of the velocity? What is the range of the shell? And how high will the shell rise? Very quickly, we're going to look at this question. It's a question on the inclined projector or projectile, so to speak. Now we're given the angle of projection, that is the launch angle, 30 degrees to the horizontal. And here we are to find the vertical and horizontal components of the velocity of the projectile. That's to be, say, at point O, which is the point of a projection. When the body is projected here, we can resolve this velocity. Velocity being a vector quantity has direction, and we can resolve it. Since the velocity has a direction 30 degrees to the horizontal, it has a vertical component and also the horizontal component. And in my last video, I derived expressions for these components of the initial velocity of the projectile, the one acting horizontally and the one acting vertically. And I said uy is the vertical component of the initial velocity, and from there it is given as u sin theta, and then ux is u cos theta, and it's acting along this horizontal, along the x axis. So with the parameters given to me, they give me initial velocity as 2 times 10 over 3, which is 2000 meters per second. So I'm going to use that. I'm to take g as 10 meters per square second. So, and then angle theta, we know that already from the question, 30 degrees. So my uy will be equal to 2000 sine 30. That gives me 2000 multiplied by 0.5. Then uy gives me 1000 meters per second. So that gives me the vertical component of the initial velocity. So to calculate the horizontal component ux, we have 1000. That's 2000 multiplied by cos 30. That will give me 1732 meters per second. So that gives me the horizontal component of the shell's velocity. That is the horizontal component of the initial velocity. Now the next question says you find the range of the projectile. What is the range of the shell? And recall the equation for range. R equals u squared sine 2 theta divided by g. If you are watching this video for the first time, I'll refer to the last video on deriving equations for projectiles. I'll refer to that video. Watch that video, you come to see the way I derived all these equations and then try to know them. Okay, so the range of the projectile, the shell, this is 2000 squared times sine 2 theta is sine 2 times 30 divided by g is 10. That gives me the range as equal to, this is 4 million, that is 2000 squared. In standard form, it is 4 times 10 to the power 6 times sine 60, which is 0.8660 divided by 10. So if I evaluate this, I have my range is equal to 346,400 kilometers or meters per second, first of all. Then you can decide to convert this to kilometer by dividing by 1000. That will give me 346.4 kilometer. That's the range covered by the projectile. The last question says we should calculate the maximum height. How high will the shell rise from the plane of projection, which is along the x-axis, to the highest point reached by the shell? This distance is the maximum height risen by the shell, and that's what we are to calculate next. Okay, let me call that C. Okay, I call this B. So the maximum height equation again, if you go back to the video I gave on these derivations, you have u squared sine squared theta divided by 2g. So my h equals, this is 2000 squared again, times sine squared 30 divided by 2g, which is 2 times 10. Now, once again, 2000 squared 4 times 10 to the power 6 times sine 30 0.5. So I put 0.5, then apply the square divided by 20. So that gives me 4 times 10 to the power 6 times 0.25 divided by 20. So by the time I evaluate this, I'll have the maximum height attained by the shell as 50,000 meters. In kilometers, this will give you 50 kilometers. That is the maximum height risen by the shell. So we have just quickly gone through the questions, from this particular example to calculate the vertical initial components of the shell's velocity. That's at point t, at time t rather, equals 0. We have resolved this before. Uy is the vertical component of the initial velocity, and ux is the horizontal component of the projectile's velocity that is acting horizontally. So we found that and then use that to calculate the range of the projectile and also the maximum height attained by the shell. So in the next video we shall see more on this projectile.